Alright, another draft physics video production and such. Another response to Franklin who seems responsive to responses, so that's good. Try to spare him, make it as brief as possible, the important points. To start with anyway, and then I can drag on later. I'll play some of his video. Just take one point at a time, I suppose. But there's, he mentions also the frustration in terms of all these, even when you can get a conversation with somebody, the conversation never resolves, in the sense that dissidents argue with dissidents, but no one ever convinces anybody of anything. And it's sort of circle jerkle, waste of time-ish kind of thing sometimes, because nothing's resolved. Nothing's ever demonstrated to be, okay, this is something we're going to assume or accept as a fact, and go from there, set up a bunch of facts, and then have an argument, and just say that's what the argument's going to be, and it's that universe. And if you're not in that universe of facts, then yeah, it's probably best that you don't participate, because we don't agree on some fundamental things. So they would probably end up doing that and going into some statement like waves are a fact or something. They're not emergent, they're somehow elemental, which is the fundamental agreement between me and Franklin, frankly. Although his ether, he does particularize it. He particularizes it into something that, in my opinion, doesn't exist, positrons or something. And which probably is harmless in some respects. But why, because then you're just making the argument that the photon is made out of positrons then, and an electron has a motor made out of positrons and blah blah blah, or some other, whatever they make up, neutrinos or something. I think maybe that's the one he uses. I don't know. Just saying. So, and then the other complexity is just, if whatever theory somebody has is usually based on a whole bunch of crap, complex crap, and especially these people, they talk about hyperboloids and toroids. I mean, so much of this dissident stuff is stuck in this swirly shit that they don't explain how it swirls. Where's the motivation for the swirl, the mechanism? They just say some field does it. It's just as vacuous as the conventional theory in terms of it doesn't provide any physics. There's no explanation of a mechanism. So I guess we'll just get to the first point, and then I'll raise the other points just to save some time. So yes, I won't go into this too deep. Just get to this first argument made by Franklin regarding how he knows what he knows, and I would argue it's not a fact.
Time varying stuff. I would argue against that. I would say that.
So we have this idea that I claim there's no evidence anywhere in the universe that a photon does this, that it's a little bit on, and then it's more on, and then it's full on, and then it's fading, and then it's a little on, and it's full on, and blah, blah, blah. None of that. There's no evidence that a photon does any such thing, that it moves through space in any other way than to arrive as a hunk of pure momentum, motivation for an electron to move. And not move a little bit, and then a little bit more, and then a little bit more. None of that crap. There's no evidence for any of that, in my opinion. No evidence, no experiment can be cited that demonstrates that.
That we know that it is time varying for, especially a radio wave, because we can stick an oscilloscope onto a radio antenna, and
so let's understand how a radio wave again is produced. My argument is that it's shooting a bunch of photons in perfect phase, and amplitude modulation would just mean that there's fewer of these little photons. Okay, so you just take some out, just send less and then more to create a signal on top of this basic frequency. So you have this basic frequency, and you just change how many of these are on and off to put music on it. So this would be but the basic carrier signal is made out of real stuff, and obviously you receive an amount of the real stuff, but the only varying part, the carrier doesn't vary. The carrier is clearly on and off, in my opinion. And so he's going to use an oscilloscope as an argument, and it's fatally flawed because oscilloscopes, you have to have them in the right mode. And in most modes that are going to show you a wave, it's in a tracing mode. That is, the little electron is going across the screen tracing. And so any input, drop a glass on the floor, any quick thing is going to turn into a trace, because it's the electron trace on the screen is moving. It doesn't stop. So it always draws a line. It can't do up and down. Okay, you can't just say on, off. You can't illustrate. Even on, off it doesn't just go, I'm here or I'm here. It doesn't do on and then I'm off and then I'm on and then I'm off, unless you set it to do that. So it won't show you reality. Okay, it shows you an interpretation of reality. And the electrical circuit, you can see, is clearly we're using an oscillator. And the whole point of the oscillator is really just saying bang, 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 bang. It's an oscillator. It's providing a frequency. It's not necessarily oscillating in some, I'm a little bit on, I'm a little bit off, I'm a little bit on, a little bit off. All you need is the on and off part. That's the only part that's critical to the function. Voltage on, voltage off. Any variation in that is almost noise. The purer the signal is, the purer the on-off is, the cleaner the whole process is. So I would argue that this is not evidence that there's any varying in the intensity of a photon as it travels through time.
And we can observe the full up and down cycling of the wave, right? It doesn't come in a clump.
So that's his assertion. So I'm saying that no, the oscilloscope is poor evidence because it's not giving you a clear view. And I would argue that if you understand the mechanics, that's why this thing gets tricky. So I could go to the evidence of photons being a clump, and I'll just show you how it's more complicated than people think, because even though I think it's a clump, the evidence that it's a clump, Einstein's evidence, sucks. So this is one of the arguments I will be making about these, what we're seeing. We don't see photons. We see their effect on electrons. So that has to be understood, right? I mean, you can't cite some evidence where we actually saw a photon, because we never see a photon. We only interpret the photon's existence by watching what electrons do. All right. We can sort of see them. We don't actually see them. We see them create a voltage. Okay, we see them create a change in either the magnetic character of an atom in terms of polarizing it, or we see the fact that current is conducted based on the pressure created in the atom. I would argue the momentum, the extra momentum, is transferred from atom to atom and comes out the other end. Okay, so that's how we see them. So let's not play games that you see photons, but you don't see them. All right, so my simple argument for Einstein's experiment is, if you just understood that the electron is on a spring, let's say, all right, and it's heavy. Let's just for the illustration of this purpose, and there's a hole here. Okay, so there's a hole that the electron will fall in. If you can compress this spring enough, the electron falls into this hole. Okay, so if you can push it far enough, it'll fall in the hole. Now the idea is of a photon, okay, is that it's not a single piece of energy. It's not like this is a photon, boom, it hits something. All right, the idea is that it has this frequency between its nodes, its intensity, however you want to describe it. Even if you think of it as a wave, it still works as understanding here's a bump, here's a bump, here's a bump. The bumps are what's pushing. Okay, so the idea would be is you're trying to have an effect, and so we shoot photons at this, and we observe that photons are going like this versus photons going like this. Okay, so we compare these two and we say, what's their effect on this thing in a spring? Well, these slow ones, the ones with humps far away from each other, intensities, I would just say photon bits. Okay, they hit it and they compress the spring, but the spring springs back, okay, because of the time problem here. There's too much time. It hits it, it lets it relax, and then it hits it and then lets it relax. So it just ends up going back and forth and back and forth and back and forth. Now, when you get up to a certain kind of intensity, all right, then you're starting to not get any, you're reducing the amount of recoil. So now, if you take this ultraviolet light, all right, and you shoot that at it, all right, you'll hit the electron this far, the first hit, and then it doesn't rebound very much, only a little bit, and then it gets hit again, it goes forward some more, and then it gets hit again, it goes forward some more, and you get the idea that now it can get to the hole and it could fall through the hole. And this is what we saw it. This is seeing, okay? All right, we see an event, we see an effect. All right, cause and effect. We see the effect, we deduce the cause. Now, their deduction is somehow the energy of the photon is what made something happen. And I would argue that there's no more energy in these little humps here than there is in these humps here. Obviously, it's just in a matter of time. You can send more of these than you can send more of these. But there's no equation, there's no equity between momentum, okay? They think momentum equals frequency. That's why they give electrons a frequency. It's because they can apply the same formulas they use for photons movement to, and they can apply it to an electron or a dog or anything, because they don't have to worry about figuring out its momentum. They don't have to do any conversions. They can just apply. They can do a simple conversion, turn momentum into a frequency, and then put the frequency into the equation and make a wave equation work to describe a Volkswagen going down the street. So it's just a trick they're using, and it's not accurate. It's not the truth. There's not more energy in ultraviolet light. There's just the capacity to, number one, satisfy a trick, make this happen where you can't make it happen with weaker light, and light that doesn't have a high enough frequency. And it's just a density per time argument. You're just saying that this form of radiation can carry more. Doesn't mean it does have more. You could have a much longer ray of infrared radiation that technically has more nodes in it, more bits. It just needs more time to get there. So these are I'm just saying that time is important because you're shooting an electron out of tension. So the tension is it's attached to a proton. All right, we know that's the tension. And so there's nothing about the electron. There's nothing about the photon that creates the photoelectric effect. It's all about the circumstance of the electron. The electron's creating the hardware. And this is true in the double slit experiment and every other experiment. Electrons are the things making it complicated. The photon is not complicated. Dirt's simple, and blah blah. So that's probably enough on that specific subject. I think I've nailed it. So I'm just saying I'm nailing evidence that's to my favor. Obviously, this was a reason why they decided photons were particles. So my whole argument is that it isn't true that you can deduce clumpness based on this fact. This fact doesn't prove that photons come in a clump, because we're just measuring one kind of photon, the one that produces the effect. So this is true for shooting an electron off of a surface. You hit it with light and you shoot the electron off, and it's also the same. It's the same basic effect when you cause a current. It's just you need less energy, and more varied energy will cause an electrical current. Okay, so you can cause the electrical current through a wire, but it's the same tension argument. So both of them are evidence of clumpness in the sense that it takes a certain quanta of energy, which means a certain by frequency. So they're just saying it really takes a certain number of impacts, to drop it down the hole in a specific amount of time. But if you hit it even more, so if I hit it and it falls down the hole, and my photon still has cannonballs, the cannonballs just go through, right? Because the electron's already done its trick. I've already made it do what I want it to do, which is go down the hole. And the more the energy I throw isn't going to make any difference. So this ray, a photon, okay, however you want to view it, you want to view it as a bunch of this stuff, it's okay with me. Just understand that this ray length is a reality you got to deal with. Okay, how long is your photon? What is a photon? Is a photon one of these little things? I think that's bullshit. I think everybody knows that can't be true. A photon is a collection of these things in a row, in a sequence. And it can be really, really long. And I'm just saying all this extra stuff would not even be, we would never even see any of the extra. We just see that it has to have a certain minimum. If I just send one of these, the electron goes here and that's it. It doesn't go into the trap at all. Nothing happens. We don't see it. We don't recognize it as a photon. So one of these isn't going to work. And that's true of our own eyes. That's already been demonstrated. And then even photomultipliers need a certain amount of energy to recognize the photon. And if you're short of that, okay, even though it's at the right frequency, it's not going to cause the effect, okay, unless it has enough nodes. And I think that's what the evidence demonstrates clearly. Now, I would still argue, again, that the explanation of quanta works. It's clearly clumps, okay, of momentum that are causing the effect. But I'm just saying the experiment itself doesn't prove the particle nature, because you're measuring the resistance of an electron to being moved. You're not measuring, okay, the substance of a photon. And anyway, the momentum of the photon, the whatever. All right, so please a little bit more.
Comes in continuous waves, and we can directly measure that.
All right, continuous waves. See, these are just nice words to play with. Now, obviously, a radio antenna, okay, again, it's producing music. It has to be continuous, okay, because it's got, it's sending 5 of them, and the next minute it's got 3 of them, and then maybe it's got 1, and then it's got 5, and to create the carried frequency. So it's got 2 frequencies, one going like this, and the other one doing your other wavy thing. All right, but they're just frequencies. That means this is just little ons and offs. There's a photon, there's no photon. So I would redraw it as photon, no photon, 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 10 of them, 5 of them, so that's how you're carrying the signal. And the same is true with light. When you use light to carry a frequency, radio frequency almost, you're doing the same thing. You're sending more photons and less photons and more photons and less photons, and putting another pattern on the carrier pattern that is the photon. The 500 nanometer wavelength stuff you're sending, the light, and then you're putting another pattern on it. And this works for FM too. It's just that FM does it by it does it not by changing the amplitude, but by subtly changing the frequency. Okay, you can, so I changed the subtle distance between these things, and that subtle change in distance will also put a pattern on the pattern. But they're just patterns on patterns, and the fundamental or elemental pattern is on, off, on, off, on, off. That's the elemental function. Not a little bit on, a little bit on, a little bit off, a little bit off. No, there's nothing waving. Again, waves can't even, there's no mechanism for this waving in one dimension in some confined space. There's no parallel to that anywhere on planet Earth except like the surface of water or something. Something that we know is a complex medium that has a surface, that has a place to expand into. That's different than the atmosphere. So then your ether has to have atmosphere around it or something. I just it can't make any sense. It's clearly the reason why we see the wave is because there's two mediums. One's is compressible and one that's not. And the non-compressible one pushes into the compressible one. So how do you make this wave crap work? It's just wrong. It's just wrong. And once you turn into a particle, everything falls into place. Everything, gravity, magnetism, it all falls into place. You can understand everything clearly instead of complexly. No hyperboloids necessary. All right, so we'll play a little bit more.
But like I said, that's kind of the difference between the radio wave and the light wave.
Okay, so let's just take that difference part, okay? What are we trying to say is the difference? I'm saying the only difference between the two is one is antenna dependent, clearly. And it just creates, everything is in phase because we're controlling the frequency. So we're just putting the clumps in perfect phase. Everything comes off in the same phase, okay? The same exact distance from each other. And all you can regulate is how many of these little bits you're throwing, really, and at what frequency that phase is. So all we control here is we can control the frequency, but we can't make them out of phase. All right, they're in phase, and that's the way they come. Light, on the other hand, it's really hard to make light in phase. So even the LIGO laser isn't all in phase. They're trying to make it all in phase, but it's not that easy to do because lasers inherently have reflections built into them that knocks everything out of phase. There's no way to control where your electron is going to be, what position it's going to be, whether it's going to be here or here when it gets hit by your photon to excite another photon to be created. You're creating two photons out of one, essentially, in a way. And you can't control where it's going to be, so the phase gets screwed up. All you can do is get it close. So it's not in phase. So this is the key to radio, is all in phase, the transmission. And the key to light is that it's all out of phase. It's individual photons, that is individual rays. So when we say photon, we really should be thinking rayton, right? I mean, I hate, that would somebody just make fun of it, but it's not a photon, it's a rayton. Okay, it's the only thing we can see. If the ray length isn't long enough, we can't see it. If it's not the specific frequency, we can't see it. So light is produced in rays, and the rays have different frequencies, depending on the light source, of course. Okay, and they're out of phase. So even when they're in the same frequency, the same distance between them, their phase is not guaranteed from the source. And so that's what light produces when we turn on the switch. Laser or no laser, this is what we're getting, rather than this we can't control, the carrier frequency. So the fundamental frequency is hard to control. Obviously we do it, we can make red or green or different colors, but we can't just do it on the fly easily. It's not easy to do. So that's the fundamental difference. And we know that these sources are not antenna dependent, just because of the amount of energy it takes to make these is higher because they're smaller, closer together. And so we can't make light sources that are as long as a radio antenna, and produce that density of light. Number one, you can just understand the density argument. Compared to radio, I mean, this is like 100 times more dense, maybe 1,000 times, right? I mean, we're talking gigahertz for radio, and we're talking like 1,000 times to get to light. I mean, you have to multiply. So I'm just saying the frequency is that dramatic. So inside of one of these frequencies in radio, there's 1,000 of these for light. So it takes a tremendously, you can understand, it's a lot more quanta. That means a lot more bits of momentum that you have to produce. So we can't play with light the same way we can play with radio, because it still takes a lot of, they use megawatts to transmit megawatts, millions of watts to pump radio into the atmosphere. And likewise, if you try to do that here, you're talking billiwatts, kilowatts. Who could afford to run a light antenna? And that gets into this argument about a distinction between antenna polarization and the photons polarization. And so we'll probably get to that, but obviously antennas can create a polarization just because of the fact that this is, whatever this force is, you're clearly producing more of it this way than it spreads this way. So there's a higher density in one dimension than there is in the diverting dimension, the perpendicular, not the perpendicular dimension, but the amount of stuff coming off of it is dense in this dimension, and it's less dense in this dimension, the round the surface dimension. So I already illustrated this in the other video, but this circumference of the antenna, that is the thickness of the antenna, this circumference is much smaller than the length of this antenna. And so clearly more content is coming off this long part than is coming out of the round part. So if you're going to have another antenna lined up with it, you need to line it up with its density. This is where there's more density. If you line up the antenna this way, you're only getting a small fraction of the density. You're just getting whatever can hit the antenna in that one plane. You're missing all the stuff in the other planes. All right. And so antenna polarization would be true for light. It's just that we can't make light antennas. It's just impractical. I mean, we probably could make a strip of LEDs and put them in a long way, and then you could see the same effect. You can detect more photons if you line up with the light. And if you go across the light, you don't pick up as many. You could call that polarization. It has the same kind of crude appearance of polarization. But antenna polarization is not polarization of the actual photon. The actual photon has to carry the polarization, and it carries it in both radio and in light. The actual photon is carrying polarization. It's not a group function from the antenna. All right. So it's not about this group of photons being polarized. It's about the fact that each individual one is carrying some notion of polarization. And as I stated, the only thing that's polarized that creates that effect is the fact that the photons are a little bit off alignment. So some of them are below the line, some of them are above the line in all three dimensions. And when you put two filters in, you hack off the ones in one dimension with one filter, and you hack off the ones in the other dimension, this dimension, with the other filter, and that's why you get no light. Okay. So simple explanation does the job.
I think that if you were be able to do the equivalent thing with a light wave, you would see in the oscilloscope, if you remember, one bump and then flat again, and the length of the bump would determine the frequency. So an individual bump you could measure just the frequency on an individual photon, and the smaller the bump, the higher the frequency would be, and generally speaking, the higher the energy.
Right. So he's still making this argument somehow its momentum isn't in its travel. Okay. See, I'm just clearly saying everything we know about a photon is that its momentum is fixed, and it's fixed by the fact that it's moving the speed of light, and it has some indeterminate component of mass. However, obviously it has no rest mass because you can't make a photon rest. And the word mass is usually associated with the idea of calculating something's rest mass, that is, unperturbed by anything in the universe. Well, clearly the argument is the photon is perturbed from its origin. It hatched from the egg flying, okay, not just sitting there. And so it's always perpetually moving. The energy of the photon never gets killed or destroyed or annihilated by anything ever. It always is having cause. It's a cause. It has effects. The effects cause new causes. That you can trace its momentum wherever it goes. You can smell it. You can smell it was there. Okay, that's how a photon works. You basically say it goes into a system, and you've got to figure out where it comes back out of the system. It's always in there, and it's always going to come back out of there. It's indestructible, unstoppable. Piece of momentum. And so Franklin's saying there's some piece of evidence somewhere that photons are only this much today, and then tomorrow it'll be this much, and maybe next time it'll be, he's saying it's some sort of varying mechanism inside of the photon. There's no evidence of any varying mechanism. There's every evidence that it's a hard piece of momentum. You can't make a half of one, you can't make a quarter of one, and you can't make a double one. You can't do any of that. It's a standard quantum clump of momentum as viewed in every experiment, I would argue. There's no experiment that demonstrates any weak photon thing. Weak element, weak node. There's no evidence of a weak node.
But that doesn't really help with the explanation of how, polarizing filters work, because I'm saying that there's actually a wave front that has an orientation that gets absorbed by the polarizing wires, right?
All right. So what he's sort of arguing is somehow, I'm certainly just saying the wavelength is clearly the distance between the clumps. The polarization is the out of alignment. He's arguing that somehow there's these elements, but they're somehow in a front. Now that you need more than one photon to do. So we know that single photons of light are polarized. I mean, I think it can be deduced to, I don't know how many experiments you can do detecting radio, because we're detecting it different. So that's another thing to understand. The radio detectors aren't detecting single photons. They're detecting enough energy going into an antenna to create a voltage, which is a little more complicated. So that in radio, you don't need the same photon to put the energy in. Okay? In the sense that one photon could do this part, and another photon could do this second bit, and another photon can do this third bit. So you don't need the same photon to provide the frequency. The frequency can be detected based on any hit from any one of these photons, where light is a specific thing where you're dealing with one electron. So you can sort of understand it, that all you need to do in an antenna is wobble electrons. You're not trying to knock them into the hole. You're just trying to jiggle them. And all you need to do is jiggle one here, or you jiggle it here. It doesn't really matter which one you jiggle. It's still going to cause an electrical current, and that's all you're looking for. And you're looking for a time varying electrical current. That is, no matter whether the on comes here or the on comes here, it's an on. And that's all that matters. And even if all of them go on at the same time, it's still on. So all you're really detecting is hit, no hit. So in some sense, it's just a different way of measuring frequency. And we can't measure light this way. We can't detect light by creating an oscillator that creates an ability to see these tiny frequency differences in the antenna. So we can't create the same kind of light detector because the frequency is just way too high.
So it cannot just be like an individual bump, because I think, like I told you, an individual wave cannot be polarized. You have to have at least a group of waves in.
Right. So again, he's saying, when he says group of waves, he's saying this group of waves, whatever, would be this way. So he's still denying the obvious, which is the group of waves is this way. This is your group, and it's a ray. Okay, and it's just more rational to accept that the ray is a clumps of cannonballs at a frequency. It solves the problem. You don't need a wave. A wave doesn't have any utility in this, in terms of understanding. It's a clump of momentum. It moves an electron a specific amount. And that's what all the evidence indicates, is the photon moves the electron. And a certain amount of movement we can see. Below that threshold, we can't see it. And above that threshold, we're not going to see it.
Your medium to describe something like an ocean wave crashing on the beach, right? So in order for me to explain that, I have to think that the photon can't in fact be just this one wave.
Right. So again, this idea of an ocean wave, everything we know about ocean waves is they're big giant things, okay, coming into the beach, all right, and that they have time differences because they're not coming in as flat waves, and that somehow that wave only hits one little piece of the beach, or one little piece over here, or one little piece over here. It's completely, I mean, the argument is that's not very intuitive. I mean, it doesn't fit with anything I've ever seen. So how do you explain how it has this tiny profile of an experience? I mean, the effect is this tiny thing, and yet you're saying the cause is something that by reason alone you can say has to be spreading this way and has to be spreading this way. Well, where's the evidence that it's doing any of that? There's not any evidence in the effects. The effects don't demonstrate it, so it's nothing like an ocean wave, in my opinion. It has no characteristic like an ocean wave. Feynman even stated that. I mean, it just isn't. Okay, it's the wrong guess.
In any way, shape, or fashion, right? You've got a three-dimensional media, and within that three-dimensional media, you have a wave which is traveling through space, like, say, my hand, right? So my hand could be considered a photon, right? And so that thing is being generated, and as it's generated, the tips of my fingers, there's like four. Let's say there's like the media is.
So this is, I sort of said that he was talking about amplitude, and what I meant by that is that his description, he's basically saying that, okay, as I increase the wavelength, okay, so this is the wavelength, the size of the hump. So he's saying the size of this, that this is somehow traveling this way, but its profile, it's this looking at it, you would see, this part, you would see this, this way, like, this idea of this is the spread, the height. So that's what I meant by his argument is some kind of amplitude argument. He's sort of just saying the wave is going this way, and these are the 5 fingers he's talking about is this distance. Now, the problem with that is the relationship between polarization and frequency is inverse. So, well, I mean, it's consistent in the sense that the tighter the frequency, the narrower this distance. The profile gets smaller and smaller. So the amount of, I would argue, I have argued that obviously it's time variant. The electron is producing the photon. The electron has more time to move out of position. Obviously the photon's going to be in different places because the electron has time to move to different places. And the higher the frequency, the less capacity for the electron to fuck the ray up. So it's straighter. So the profile gets smaller with the higher intensity light, that is the light that's supposed to have more bang for the buck. So those two things don't fit either by that theory. So he's basically just saying photons are a blob, so that's a photon. Its frequency is its fatness, okay, and but somehow its polarization gets smaller as its fatness gets bigger, in the sense that its intensity, its ability to affect something. The higher the frequency, somehow his clump would have to get bigger, not smaller, because it'd have to get more intense somehow. Well, anyway, so let's just ignore that part. But yeah, he's saying this is a photon. A photon is like a one thing. It's a one It's a one wave, one little lump, there, wavelength. There's a wavelength. Okay, node, node, node. That's a photon. Okay, and photons aren't ray dependent. They're just this is it. That's all. That's always a photon. Every photon is that. And it just can't work as an explanation. It can't do the photoelectric effect. It can't do any of this stuff in any way you can rationally explain. So, but he's just giving the shape. He's just saying a photon has its polarization is essentially, it's a frisbee. Let's just call it a frisbee. And he says the frisbee flies this way or the frisbee flies this way. So that's all he's doing. He's giving shape to the photon, and I was comfortable with that analogy. I still am as an analogy. But, and I even a few years ago would say I was thinking photons maybe had a shape. But it's unnecessary, and it's something else you have to explain then, because the shape changes so much depending on the form of the radiation. I mean, am I really going to argue that the radio wave is, a photon in a radio signal is actually miles long, and that it's miles across? The single photon is some giant, huge, filling a whole giant hunk of space, miles wide and miles long? No. When the simple explanation, it's just the distance between the pieces of momentum. The momentum have a distance between them. There's nothing here. Okay, zero, new, zero, and there's something here, and the something is a little tiny thing with a very high velocity.
It's at least 4 units wide, I guess, right, within your media. So these 4 things can head out, but as they're generated, they can be at any angle, right? They could be this angle, they could be at this angle, they could be at this angle. But it's kind of like jets flying in formation, right? Kind of like the blue.
Yeah, so it really is sounding kind of, like, no, that's really doesn't sound like how it works, because he's just basically turning this into this, somehow saying the photon travels through space this way, like that. It's a ray, but it's this way. It just doesn't work, I don't think.
Angels, right? They're coming in. They're all together. The polarization is determined by the unification of their wavefronts as they come through, right? So that determines the polarization angle of the light wave. And then, as it hits the polarizer, then we use the same logic as we use for the radio wave.
So the key difference between the radio waves, as I'm trying to point out, is that essentially they have 2 polarizations. The individual photons are polarized, okay, and coming off the radio, they still have this erratic alignment, however you want to describe it, and then the antenna is also creating a physical polarization in the sense that the density of the stuff coming off is higher in one dimension than it is in the in-out dimension.
Which is that if it hits if I have my jets here and they go and they fly into a vertical pole, all 4 of them are going to crash into the pole, and that's going to be maximum energy transfer, right? And just like the radio waves, that wave gets absorbed and it cannot pass through the filter.
Right. So now we have another concept of what exactly does the filter do. And as I did point out in the subsequent videos, that frankly, he doesn't apparently watch my channel, so he didn't see the subsequent videos on polarization. But there's a real debate now, in terms of understanding these different kinds of filters. So in radio waves, they are using hard objects as the filter, metal. There's every probability that there is absorption when the stuff hits, but there's also the idea that technically this becomes another antenna and it can just readmit the energy also. So it absorbs it but readmits, Okay, so that's a theoretical possibility, certainly. And the idea is that polarizing filters don't apparently get hot, which gives us some indication that the energy doesn't stay in the filter, that the filter material is not absorbing, that what these things, these lines are, is just a phase shifter. So each line shifts the phase of the photon. All right, so you have a phase shift, no phase shift, no phase shift, phase shift, no phase shift. And obviously, if let's just take his example of something that had a polarization in a direction, you know, a mass heading for this filter, there would be this obvious thing. If it comes in this way, you know, at an angle, and it hits this filter, well, each object might be exactly at the right place to hit none of the phase change, so all four would get through. But if one of them hits the phase, okay, let's say this one hits this phase shifting material, then it's going to be behind now because it's been phase shift. And so what you'll get out is this, you know, well, his are all in alignment, you know, missing guy, then guy. And so the missing guy is here. Okay, in his example, it's moving this way. So the missing guy is now out of phase. So you don't have sufficient photon here to register the photon. And the way you can fix it is you'd have to get this guy back in phase again to fix it. So then the second filter at a different angle. These other three photons might get hit on the phase. And so this guy would be now lined up with these guys because they got knocked out of phase. And so now it's back to being a recognizable photon. Now that's not what I think happens. You know, obviously I think the planes are lined up. Here's a plane. Okay, here's a plane. There's a plane. Here's a plane. Okay, it's not planes parallel to each other. It's planes in sequence, and the sequence is the frequency. But the same argument I would make. So when it goes through the filter, because they're out of alignment, the planes aren't in a perfect line, then one of them hits the little phase shifter, gets knocked behind. Now he's out of phase with the others in terms of now you've broken your frequency. And the way to fix it is to get these other ones that are a little bit out of different alignment to hit those and knock those into the same phase. And then you're back in business because now you have enough energy to kick the electron that's on a spring. And you can make it fall down the hole. Okay. But it's really important to understand that each one of these materials is subtly different, and we shouldn't assume they're all doing exactly the same thing in terms of absorbing. Now you can break the photon and indicate polarization, but if you want to do that three filter trick, okay, one filter this way, one filter this way, and one filter this way, the fixer, right, the one that seems to fixer, that seems to just, you know, there's no light gets out when these two are in play, and I stick this one in the middle, and all of a sudden I get 40% of my light. Somehow it fixes what this one broke. So obviously the photons made it through the filter. They're still there. They're just not in the right sequence, so they can't be understood as a photon. It can't be interpreted as a photon by the electron. And the fixer, just by circumstances, fixes some of those broken photons. Puts them back in phase.
But if you have the radio waves going this way, and they're like jets hitting through a vertical pole, chances are they're all going to miss, right? Not unless it just hits directly head on to that one little pole that's just sitting there, right? So those will be allowed to pass, right? And then if you put it through another filter in the same direction, then they will continue to be allowed to pass through that, right? But if you put then another filter that is the opposite, the way that will absorb them, then they will be completely blocked, right? Since you will have eliminated all the other angles, that this direction is going to block you. So I think that's an interesting analogy. It's like I just came up with that. It's just like Blue Angels. You have it.
Yeah, well, the problem with anything is they always have to start with, it's like talking about the single slit or the double slit or any of those experiments. We know it's a single photon phenomenon. So that's a point where we have to start. And then what gets confusing, again, is when now you go, so you take that assumption and it works fine, okay, you stay within that boundary. We understand that this is a phenomenon that single photons do, this moving in the wrong direction. But then you get to something like the interferometer, and all of a sudden now it's not single photons, now it's multiple photons are somehow interfering with each other. In the radar experiment, for example, and all of a sudden the interference patterns being created by fundamentally different photons coming from two separate locations that are somehow interfering and creating wave functions that interfere with each other. So there has to be a consistency somewhere. So I'm arguing as soon as you take your examples and analogies and start talking about group behavior, that is the group that comes off of a radio antenna, for example, it's group behavior that we're measuring. Okay, we're not measuring single photons in that case. And you're saying there's group behaviors. Well, what we understand is that this idea of polarization, though, is something photons have. So you always have to stay in that boundary of the conversation, the premises that we can agree on. And that's the whole problem with these conversations, is they start drifting into places where there's no agreement. I mean, what's your underlying premise? That interference is, do you think individual photons break into wave functions, interfere with themselves?
So your plane's flying information, that direction is actually the polarization angle that the photon has. And like four planes, they have a fixed dimension to them, and they have a beginning and an end where they happen. But they're not a clump, right?
Well, again, as I've pointed out, they're not a clump in that there's no such thing as this being called a photon. Okay, this isn't a photon. Okay, so obviously they're not a clump. Even in your wave idea, you have this happening and then you have this happening. Your single wave function has more than one component right in it. So it's obviously not a clump in the sense that it's made out of a this and a that. So it's obviously not a single clump. It's a clump that has to be made out of elements. And I'm clearly arguing that a photon is a clump in the sense that you must have a clump of momentum, a time variant, a time dependent momentum, okay, is what you need to perturbate an electron sufficiently to create the bell going off, to ring the bell. You have to compress the spring. So there's a rule about what compresses springs, and I'm just saying that obviously the photon is a clump in the sense that you will need a specific arrangement or amount of energy to ring the bell to say photon came here. Now obviously I'm saying there's a bunch of this other bits of energy that's in different forms, okay, that's filling the universe, and that's also causing gravity. Okay, so clearly there's a whole bunch of broken photons that are in the environment all the time and inside the matter all the time, creating what we see as heat. Again, we only see things as they manifest. We don't see them, as we can measure them, all right, detect them. They can exist in other forms inside of something, but we only see a signature, the smell they produce. We can only smell the heat. We can't really measure the heat because it has to have some kind of effect on the material that says, oh, it's producing infrared. Oh, it's producing something that indicates its temperature. But we can't see the temperature.
And they do have, I would say, this maximum and minimum kind of behavior. And it would be kind of interesting to see whether someone could actually measure that. I mean, if you were to look at photons individually, I think that you would see that kind of data, and I think that they do have some like ultra fast pulse experiments where they're doing things like measuring the speed of light.
Well, I don't think they do, frankly. Those photographic experiments are just kind of gimmicky, okay, and where they're taking 1 million photographs and creating some version of a reality. But they're not even photographs of the same event. They're photographing the same event 1 million times and taking slides from the different events. So, it's not reality. It's a nice picture, but it's not really reality. But clearly there's no evidence that photons are really being watched. Um, what did I want to emphasize here? So we do have some evidence of the variability of the what's defined as a photon. And I'd say the evidence is that we know our eye is triggered by a certain number of these nodes. Okay, you have to have a certain number, 6 of them, to have a photon registered by our eyeball. And we know that a frog only needs, let's say, 4. And then we know that we have a thing called a photomultiplier, and then we have a photodiode, both working on different systems, but the same ideas. They can detect a certain amount of this energy. Now we know if we turn the photodiode up, way up, and it starts detecting, say, 2 of these or 3 of these, we don't know which, it might be 10 of them, it might be the real minimum, that it starts seeing photons everywhere, which is almost me saying it starts to see gravity. It starts to see all the energy that's around that we don't see. Okay, it starts detecting everything at a high, at the right frequency, but not enough frequency for us to see it as light. And I would argue that there's little pieces of microwaves out there. There's little pieces of radio out there. They're just too small a piece. They're not enough. You need enough frequency. Okay, you need enough length of the ray of the force of the energy. You need a ray length. Okay, you need a sufficient ray length to be able to say I saw it. It's critical. So again, that's the point, is that we do have instruments that we can make more and less sensitive. So in a way, we can see that the photon does have it comes in these forms. You'll see more of them if your detector only needs a small ray. If your detector needs a big ray, then you see a lot less of them. It's really that simple.
Light and stuff like that. And when the charts do show that, it's not like a square wave. It's not just like there is a definite rise and a definite fall.
No, there isn't. You have no evidence of that. You have no experiments that demonstrates it. There's no evidence. You just misinterpret. You don't. I mean, I'm not saying you have to understand how oscilloscopes work, but I'm just saying that pattern is just a human-friendly way to view frequency. Those patterns, those tracings you see in an oscilloscope aren't tracing the actual energy of photons. Again, the instrument can only detect the photons or the radio waves by detecting their effect on electrons. And clearly electrons, you could argue, I don't think they have a momentum problem, in the sense that I think their momentum is clearly quantized. They get hit by one little bit, they'll move a certain distance at a certain velocity, and that's all pretty regular. They don't accelerate and decelerate. They go 50 miles an hour, they go 100 miles an hour, they go 150 miles an hour. They don't ever do the in-between parts. And I think that's demonstrated by the function inside of atoms. This lack of variability in their momentum is clearly an indication of the whole idea of the what do you call them? The rings of the atom. What can I think of that simple word? The electron's orbital distance, whatever the fuck that is. Anyway, clearly that quantum jump idea. It jumps to a new momentum. It doesn't take any time to get to the new momentum. It either has it or it doesn't have it. It's going 50 miles an hour or it's going I would argue it's going 50 miles an hour the opposite direction. That's its only choice. 50 that way, 50 that way. Then you hit me again, I can go 100. Then I can go 150. So you can give me more momentum in a direction, but I can only do it in these quantized Planck constants of momentum. I think that's all. I think all the experiments indicate the clumpiness.
With that, they think that would be consistent with the idea that we're dealing with a compression wave, that it takes a finite amount of time for the wave to rise and fall. So that's the way.
All right, well, just cite some experiments then. Cite some experiments that are doing rises and falls, and I'll just point out how, no, you have an oscillator in your circuitry, and you have a resistor and a capacitor, and all you're really doing is you're causing it to become a wave. It's not a wave. It's an on, and it's an off, and it's an on, and it's an off.
That I think that probably works, and so that would be my response to Gary. So, once again, thanks for tuning in, and hopefully you kind of understand my viewpoint on this. I think I kind of understand your viewpoint a little bit, that and it's helped me kind of.
Yeah, well, I don't think you do, really, because then you just say, oh, yeah, you're right. It's so simple, so obvious. It fixes everything. We just forget the waves. It's all just packets of momentum, packets at a frequency. It works. It explains everything. The electrons are the ones creating the limit. They're the ones saying, I need a clump. The electron's saying, clump me. And if you don't clump me right, I ain't moving. The electron sets the limit of our visibility. So it has nothing to do with the photon, essentially. The limit is set by the electron. It says you need this minimum amount of action. You have to hit me you have to punch the bag at my resonance. And if you don't, the bag gets all wobbly. If you hit the right resonance, then I do this beautiful blah 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 thing. It's wonderful. It's all smooth. The engine runs good, okay, when you have the timing right. Timing's wrong, engine runs like shit. And it's that simple.
To come up with this new analogy of the Blue Angels, 4 planes flying in formation that actually delivers the polarization.
Right, again, just turning this wave into this wave, which doesn't make any sense at all. They're not coming at the same time. They do in radio waves. Like I said, radio waves, you're essentially turning the thing on, because the clumps will be hitting, in the same phase at the same time, and so they're not dependent on one ray creating the effect. You don't need one ray to cause the effect. The effect can be caused by pieces of different rays being at the right frequency. Partly why radio picks up the cosmic background radiation. It picks it up because it just needs little pieces at the right frequency. As long as there's enough little pieces, you can still pick it up. And that's the irony. The radio antenna is basically showing you, the background radiation.
Rather than say your idea, which is they're just like planes, but they're flying in all kinds of directions. But actually, maybe it's the same thing almost.
Yeah, well, that's the whole point. I was trying to illustrate. Yeah, so he's trying to make this distinction. I'm doing the logical thing that's saying the planes are at a frequency. They're at a distance from each other, and all I'm arguing is they're out of alignment in 3 dimensions. So we just say, we can just add another dimension here. This is the in-out dimension, and this is the up-down dimension here. So this one's out of alignment up-down, and this one's out of alignment in-out. And so, this is your ray, essentially, and they just have a little bit of an alignment problem that creates polarization. You're saying that the whole frequency is coming at it this way, so the frequency of the photon is somehow going this way, which doesn't make any sense, because obviously all the planes are going to get there at the same time. So that can't possibly work. I mean, the planes can't all get there at the same time, and you say it's still got a wavelength, and clearly the planes aren't going to be 10 miles long. I mean, that doesn't make any sense to me. Sorry, that's wacky. This plane is 10 miles long? No, no way. No chance.
Kind of. But the nature of the actual blockage would be the same as you described for radio. It's just a matter of building the most.
Okay, so let's understand that we've assumed blockage. I assumed it. Okay, until 2 weeks ago or 4 days ago or whatever it was, I assumed it was getting blocked. But that's an assumption, right? And it's, in my opinion, it's the wrong assumption. The energy, there is equilibrium arguments here. There's retransmission arguments that all the energy does come out in another form. So instead of saying blocked, what we should say is broken, okay? What happens is that the visibility is broken. So something happens to the photon where it goes in and somehow it comes out, not so good. And so this can't be seen, this can be seen. That's the difference. And we can restore its seeability by sticking another filter in there, okay? And now we can get this back to being this again, okay? At least some portion of it. And restore some of those formations, so now we can see the pattern again. It breaks the pattern. And photons are all about pattern. The pattern's created by the frequency and the amount of variation in location of the elements of the frequency. And we can only see patterns within a rigid construct. Anything outside of that construct, the electron won't receive it because it won't compress its spring just right. It'll compress it wrong.
Effective receiver for the kind of waves that you're generating. So, in some ways, the four planes are just like your photons being not all exactly in the same place. But the important thing is that you get your photon, your individual waves, whatever is creating these things to line up, so that you can describe this this transverse.
Yeah, no, the lining up is wrong because that's not a frequency. That's not time dependent. Again, if I put all of these lumps here, lump, 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 I'm not creating a frequency anymore. I've broken it. And again, this is just dependent on you saying it's intuitive to you to think of this time varying thing happening and stretching it out, whatever this is, like a giant piece of spaghetti with a loop in it or something, and somehow the loop matters. It doesn't even make sense. How does the loop matter to the electron? How does the electron care about this loopy crap? It cares about momentum. It's an Earth and it has to be hit by an asteroid. It can't be hit by a piece of spaghetti. It can't mean anything to it. The small universe, is duplicated in the big universe in a lot of respects. It's clumpy.
Polarization direction, which is perpendicular to the direction of travel. Right? That is the fundamental thing that we have to deal with. So let's see here. Hope I didn't lose everybody. I was kind of wondering, maybe we have some comments here. So let's go to comments here.
Some of them are kind of funny, actually.
So we have some people here.
So let's go down to this one cranky guy who is just so obnoxious. So Harry Rinker. Franklin needs to be replaced since he doesn't know what he's talking about. Obvious that he doesn't understand the basics of EM theory. This discussion is ridiculous. So attempting a discussion about some fundamental element of physics like polarization, Harry thinks he knows the answer. He's got the definitive answer of what a polarization is, and he doesn't need to talk about it anymore. And so he's just a perfect example of the closed mind of the conventional physics nonsense. They have a nutty theory that can't be understood. I can't understand any of that wave crap at all. Can't figure out how it does any of this stuff. There's no explanation for why it has this kind of whatever herky-jerky motion. I don't even know how this motion manifests itself. This compression wave that doesn't spread, that's just a lump of wave in the middle of three-dimensional space. It's crap. It doesn't make any sense. And yet he's certain he's right, and that anybody who attempts to understand the mechanism and explain it from a more elemental way, and even if they do it wrong, he's against having the conversation. I mean, it's just amazing. And he has nothing to, he has nothing to add in terms of a constructive criticism, pointing out an experiment that proves any of this speculation wrong. He's not explaining to Franklin why, well, you can't line up the planes all in a row, parallel to each other. It just doesn't work. You've lost your frequency then. And you've certainly lost your ability to transfer the momentum, because now your planes are going to get wider than your electron, and you're not going to be able to hit the electron with all your planes. Some kind of argument with that. But there's just nothing like an attempt to have an argument, to make an argument. There's just insults.
So we have a question from Jim Martson, which is a photon a soliton? Now, that's a good question. Okay, I think definitionally, a soliton is that single wave.
All right, so this gets into, they start talking about all kinds of magnetic and electrical theory that doesn't really have anything to do with polarization, so they kind of fall off the subject. And so I didn't know there was a word called soliton. I thought this was an invented concept, but he's basically saying a soliton, by some definition, is this single wavelength. So, I mean, I would obviously say, I'm not going to call it a soliton. That's just, I'm not going to. I want some other word. An element. So that's clear. I would argue that, yes, photons are made of these elements. It doesn't have these two humps in it. It doesn't have any of that crap. It's an element. Okay, and it's at a distance. And the distance can be node to node or hump to hump. It doesn't matter. It's the same. So it's just a distance between this one and the next one. That's always a fixed distance. To be a photon of a specific frequency, then each little blob, each soliton has to be at the same the same distance. And then you have whatever this is, we'll call this a photon. So a photon is clearly made out of elements. And if those are what that other Bill guy means by a soliton, then I could agree that solitons are the elements of the universe. This is what makes the universe. This is gravity. This is magnetism. And all you have to do is give this stuff two colors, to create magnetism. Two kinds of force, two kinds of matter, proton and electron, proton. So you have two kinds of force, you have two kinds of matter. The two forces interact inversely, which means that whatever the proton's excreting, the electron's excreting the opposite kind of thing. And now you have magnetism. When you tie these two together, you have a dipole. When they're individual, you have charge and the magnetic monopoles. These are the magnetic monopoles right here. Quite obviously, they completely fit the description. If you were to describe what a magnetic monopole would look like, you'd end up with a description that was identical to the electron and the proton. It's so frickin' easy and simple. So anyway, I guess we'll call that a video. Don't want to go way too long. I appreciate the conversation, Franklin, and I suppose, like I said, I like that just as advice, you have to stay on subjects, and don't beat them to death because it just gets boring if the subject's not going anywhere. So that's good. Polarization's a good subject. And you really have to start itemizing things that are going to be stated as facts, and then as premises for the argument, and then just see how many people say, I can accept that fact. I mean, maybe this whole group just wants to talk about different versions of a wave theory. So you establish that you're saying it's a wave. I'm saying that's easily contended as a fact. That the evidence that there's any wave functions involved with a photon, the evidence is almost non-existent, frankly. I mean, the subtle seems like evidence of, well, I see an interference pattern. Again, the simplest pattern in the universe, the on-off, on-off, on-off. Hardly conclusive evidence of wave behavior, or that it is in fact a wave function in any way whatsoever. It's a function of tension. You're hitting something with momentum that's caught in tension, and frequency matters then. Resonance matters. Constructive addition of momentum matters. Constructive and destructive addition of momentum is what we're talking about. Now that can look like wave interference, but that's what we're really talking about, is can you constructively add to the electron's momentum, or are you fighting the electron's momentum? Are you trying to change the electron's direction, or are you adding to the electron's momentum, its speed, in the direction it's already going? Key, that's all there is. There's no waves. Alright, anyway. So, till next time, and such.